Good morning, I am Renu Sharma, Assistant Professor EC Department. Now, today I am going to start with the next lecture of this subject, that is wireless and mobile communication. Today we will discuss cell infrastructure. So, these are the topics of today's lecture, that is introduction, then cell splitting, cell sectoring and microzone cell concept. So, all these are part of cell infrastructure. So, first we will begin that what is cell infrastructure, why we have to learn about this. So, as number of users increases, the number of channel assigned to a cell become insufficient to support large number of users. So, therefore, cellular design techniques are required. So, what does it mean? That with you all are concerned that this internet has number of users has increased, but from the last 2 years in this pandemic situation all things are being digitally done, and it requires large spectrum to be used. So, number of users means if you want to, I am talking about this education industry also, when you want to means in school also you have to attend the classes on mobile phone. So, that requires, that has increased the number of users. In last 2 years it has a drastic increase in number of users or the number of channels that has been required. So, what we are talking about here, that let us see that a particular area is divided in this cell, and if the number of users in this particular cell has increased. So, which means we have to divide this particular cell into smaller cells, so that every user has require proper frequency, set of frequencies, means an efficient utilization of the frequency will be there, and every user will experience a stream, a very nice connectivity of the internet. So, that the call will not be dropped, or if they are attending any class on mobile phone, then it will not suffer due to the connectivity. So, that is why we have to reduce the cell of the size. Initially I have discussed that it is inversely proportional, size of the cell is inversely proportional to the population, means the population, if it is large, then the size of the cell should be small. So, that every user acquire a proper connectivity during the call or during the use of internet. So, the cellular design techniques which are required to provide more channel per unit coverage area. So, first one is the cell splitting, cell sectoring and microzone cell concept. So, these are the three concepts that we are going to discuss in this lecture, which will going to give you an idea that how these particular cells are splitted or these are divided. So, first we will see what is cell splitting. So, the process of subdividing a congested means number of users has increased in a particular cell into a smaller cells, each within its own base station, and a corresponding reduction in antenna height and transmitted power as shown in the figure 1. I am going to discuss in the second slide, figure 1. So, which means that a congested cell we are considering where number of users has increased from the previous time, and we have to split that particular cell. So, the cell splitting reduces the transmitted power, because we are dividing the cell into smaller one, but we are using the same antenna. We are not changing the antenna that we are using previously. We are using the same antenna. So, it will basically going to reduce the transmitted power. So, the quality will be going to suffer. So, the original base station A has been surrounded by 6 new micro cell. The smallest cells were added as to preserve the frequency reuse plan. So, now it was placed halfway between the two large stations utilizing the same set of G signals, that is the signals that has been allocated to particular user. Cell splitting increases the capacity of a cellular system. So, basically it will going to increase the capacity of the cellular system in number of users has been increased in a particular cell. It increases the number of times that channel are reused. Then by defining the new cells which have a smaller radius than the original cell, and by installing the smaller cell. So, which means that we are reducing the cell by its own, and also it will going to increase the number of times that the cell will be used. So, due to the additional number of channels per unit area, which means that we have increased the number of channels in a particular area, the cell splitting is a very nice concept. Now, this is the diagram which is showing that this is the original size of the cell and we are reducing the size of the cell like this one, this is the smaller cell, because the number of users in this one, these cells have been increased. So, to maintain the connectivity, we have to reduce the size of the cell. Now, area of the bigger cell we can consider as A naught, that is the reference area, it is considered as pi r square, and the area of the smaller cell, which is r by 2, pi r by 2 square, which means the original radius of the cell is r and the new radius will be r by 2, formula is same, that is r by 2 whole square. So, which means that is reduced to this formula. So, we can consider the relation between the area of the new cell and area of the old cell, which means that A n will be is equals to A naught by 4, means area of the new cell will be equivalent to the area of old cell divided by 4. So, this is the new formula of area of the new cell. So, therefore, new area is 1/4 of the older area. So, this is the main reason behind this area, that is new area is always it is 1/4 of the older area. So, this is the formula, A n will be is equals to A naught divided by 4. Now, next one is the cell sectoring. So, this is another way how we can divide the number of users in a particular cell, so that they can the connectivity will be maintained, the quality of the call which has been set up will be maintained. So, the technique for decreasing the co-channel interference and thus increasing the system performance by using the directional antenna is known as sectoring. There are two types of antenna that we learned, that we used in cell infrastructure. First one is centrally excited, which means that particular antenna is omnidirectional antenna and it is installed in the center of every cell, which will going to provide coverage equally in every direction. Second type of antenna is the directional antenna. There are different types of directional antenna, you can use any one of it, which will going to depends on the application. So, the directional antenna will be installed at the edges of the hexagon. So, sectoring can be done at 60 degree or it can be done at 120 degree. So, in this case the sectoring is done at 60 degree of division, and in this case the sectoring will be done at 120 degree of division. So, which means if we are dividing a particular cell at an angle of 60 degrees, so 6 small cells or 6 small triangles will be generated, and at every edge you are going to install a particular directional antenna. Same is with this one, that is 120 degree. If in this case the population size is quite large as compared to this one. So, you can divide a particular area into 3 zones also at an angle of 120 degree. So, co-channel interference in a cellular system may be decreased by replacing a single omnidirectional antenna at the base station by several directional antennas, each radiating with its own specific sector. So, these are the 6 sectors corresponding to figure third one, and this is the sectors which are divided into 3 cells, that is related to the 120 degree angle. So, that is cell sectoring 120 degree and 60 degree. Now, this is the concept of sectoring. You can see over here that 3 directional antennas are installed at 3 edges, that is sector 1, sector 2 and sector 3. So, to cover every sector in a cell we require 3 antennas instead of single omnidirectional antenna, which will be excited at the center only. Antennas are not placed near to each other, otherwise adjacent channel interference will take place. So, there is a location that you have to consider for placing or installing the antenna, like in this case you have to leave one edge, and means adjacent edge will be installed with the directional antenna. So, by cell splitting it will going to increase the number of channels, and this is achieved by decreasing the cell radius and keeping the co-channel reuse ratio d by r as constant. So, basically d by r ratio has to be kept constant, and it has to be maintained, that how these antennas will be installed. So, cell sectoring increases the number of channels, and this is achieved by keeping r constant and d by r decreased. So, that is also another case that r should be made constant, the radius of the cell will be made constant, but the d by r ratio will be reduced. Sectoring increases the S by I, that is signal to interference ratio, by using the directional antenna. So, that cluster size may be reduced. Capacity improvement is achieved by reducing the number of cells in a cluster. So, thus it will going to increase the frequency reuse concept. So, to do all this, we have to reduce the interference without decreasing the transmit power. So, this is the concept of cell sectoring. Now, third one is the microzone cell concept. Microzone cell concept is the third one, the third type of division of a particular cell. So, problem with the sectoring, why we have to move with this microzone cell concept. In case of this sectoring, even inside a cell a handoff will be required. So, inside a cell we have to do a handoff, means we have to move from one cell to another cell. So, to load on the which will going to load the MSC, load on the MSC has been increased. So, to reduce that MSC, because once the MSC will be overloaded, then it will not going to make the handoff or provide the proper connectivity, to provide the proper connection between the two subscriber will not be maintained. So, the loading on the MSC will be reduced, it should provide a smooth operation to every user. To overcome this problem, we divide the cell into further 2-3 zones. So, this technique is known as microzone cell concept, and it is introduced by Lee. So, this is the microzone cell concept. This is the figure showing the microzone cell concept. Now, you can see over here that there are this is a single cell, and it is divided in 3 zones, that is zone 1, zone 2 and zone 3. So, there are transmitter and receiver which are used over here. It is connected to a zone selector, means you can select any one of the zone, either zone 1, either zone 2 or zone 3, and each of the zone is connected with this optical link, which means optical fiber cable. Fiber cable is used. Now, this why we are using this optical fiber cable, because it provides a greater good quality of connectivity, it provides a good connection between the transmitter and receiver. So, we are using this zone selector, which will going to select these any one of the zone, either zone 1, zone 2 or zone 3. Now, it is connected to the base station, which means that initially we are connecting the cell directly with the base station, but when we are but when we have come across this concept, that is microzone cell concept, these 3 zones are selected by this zone selector, and it is connected to the base station, and after this base station it is connected to MSC, one of the MSC, and then it is connected to GMSC, that is the global mobile switching center. So, these 3 connections are made, that is mobile switching center, then global mobile switching center. So, that is the main idea behind zone selection. And you can see in this diagram that directional antennas are used. This is the directional antenna which will going to cover this area, this is the directional antenna which will going to cover this area, this directional area will going to cover this particular zone. So, that is the microzone cell concept. Now, the construction of this one we will see. Each of the 3 or more zone sites, we can divide more than 3 zones also, but 3 is more convenient to understand. So, each of the 3 or more zones sites are connected to a single base station, and it will going to share the same radio equipment, that is the base station as shown in the previous diagram. Means a single base station can going to cover more than one cell, single cell. So, the zones are connected by coaxial cable, fiber optic cable or microwave link to the base station. Means if we are considering the wireless connection, then microwave frequency range will be considered, and if we are considering the wired connection, then either the coaxial cable or fiber optic cable, depending on the application, depending on the number of subscriber, depending on the area where we are going to install this connectivity, we can use either coaxial cable or we can use optical fiber cable, any one of the particular diagram we have used. So, multiple zones and a single base station make up a cell. Now, what is the operation of this microzone cell concept? So, mobile within a cell is served by the zone with the strongest signal. This approach is superior to sectoring, since antennas are placed on the edges of the cell and any base station channel may be assigned to any of the zone by the base station, which means that every approach is superior to sectoring, since antennas are placed on the edges, which means directional antennas are used again in this concept, because in cell sectoring also we are using the directional antennas, we are not using the centrally excited antenna. So, any of the concept we can use. A mobile travels from one zone to another zone within the cell. So, it retains the same channel basically. So, this is the main idea behind microzone cell concept. So, unlike in sectoring, handoff is not required at the MSC when the mobile travels between the zone within the cell. So, which means that whenever the mobile is moving from one particular zone to another zone, then it will not going to cover every area. So, handoff is not required at MSC when the mobile travels within the zone cell, which means that first type of sectoring that we first type of handoff that we have learnt is intra cell, which means when a phone will move from within the cell, then the handoff is required. But in this case, microzone cell concept, when moving from one zone to another zone, then handoff is not required. That is the main advantage of using microzone cell concept. Now, next is advantages of this cell division. Interference is reduced as the given channel is active only in the particular zone in which the mobile is traveling. So, first advantage that we have learned in the previous slide, that handoff is not required when moving from one zone to another zone. Secondly, interference will be reduced as we are moving from one channel to another channel. Now, increase in capacity, that is without degradation in trunking efficiency caused by the sectoring. So, that is the main concept of cell sectoring also. So, while the cell maintains a particular coverage radius, the co-channel interference in the cellular system is reduced, since a large central base station is replaced by several low powered transmitters on the edge of the cell. So, that is the main advantage of using the cell that will going to maintain the particular coverage of the radius. Now, the decreased co-channel interference improves the signal quality. So, that is how the signal quality will be maintained, it will going to improve the signal quality when it is the co-channel interference will be reduced. So, that is the main advantage of using this microzone cell concept. So, in this lecture we have discussed about how this cell splitting or cell sectoring is required, how this particular thing has been all set up. Cell splitting is there, where we are going to split the cell. It can be splitted into two cells, it can be splitted into more than two cells also, means every cell which will going to increase the capacity of a particular zone. In case of cell sectoring, we have divided the cell into different sectors which is of equal length, which is of equal dimension. It can be of 60-degree dimension, it can be 120 degrees dimension, which will going to divide each cell into small areas, and it will be divided into different one. So, the co-channel interference in a cell, it will be reduced in case of cell sectoring. Then we have moved towards this microzone cell concept, where the different zones will be created, and it is the main advantage of this microzone cell concept is that when we are moving from one particular zone to another zone, then handoff is not required, and it will going to maintain the quality of the signal, and directional antennas will be used. That is the same thing that we have learned in microzone in the cell sectoring. So, this is the diagram of zones. 3 zones will be there. We can consider more than 3 zones, like at every edge you can install a zone, and for that particular thing, what is the disadvantage, that larger number of antennas to cover each zone we require. So, that is the microzone cell concept. Now, apart from this zone selector, like there are 3 different zones are there, or it can be increased to more than 3 zones, that is 6 zone it can also consider. So, there are different transmitter and receiver antennas are there, and these are nothing, these are directive antennas. Now, there are 2 types of antennas. First one is directive antennas, second one is omnidirectional antennas. In case of omnidirectional antennas, what is the main advantage, or you can say the disadvantage? Main advantage is that it will be installed at the center of every cell, and it will going to cover whole cell. So, that is the advantage of omnidirectional antenna. But when we are dividing this particular cell into different zones, or cell sectoring or cell splitting, then the coverage is not maintained, or it will not be of great requirement as compared to the previous case. So, that is the main disadvantage. Now, this next one is the directive antenna. So, for omnidirectional antenna, the gain of the antenna will be is equals to 1. It should be expressed in decibels only. The gain of this directive antenna is related to the directivity. Directivity is basically it has the efficiency, G is the gain and D is the directivity. Now, this is nothing, it is related to the directional antenna only, when the information will be transferred only in one direction. So, this is the formula related to the directive antenna only. In case of this omnidirectional antenna, where the information will be transmitted in omnidirection means it will going to locate, or it will going to transfer the information equally in every direction. So, that is the main aim of microzone cell concept. Now, this is the optical fiber cable. Now, you can see over here that there is a zone selector which will going to select any of the zone, means if there are 6 zones are there, like 1, 2, 3, 4, 5, 6. So, 6 edges are there, it can be at a maximum power 6 zones will be considered, or we can consider 3 zones also, which are present at the 3 sides of the antenna. Now, at every edge you can also it can be edge excited, or it can be side excited also. So, at the means 6 zones are also possible in this case. So, that is the zone selector case, and this one will be the base station controller, which will going to control the base station. So, that is the concept of base station controller. Now, this is the microzone cell concept. These are this is the construction and operation. Construction, I have told you that single base station is there, it is connected to a single base station. We do not require to install more than one base station, which is connected to a single MSC. Then it can be connected through wired communication, it can be connected through a wireless communication. In case of wire, depending on the area it will going to cover, it can be coaxial cable, it can be fiber optic cable, and in case of connection less, we can move to microwave frequency range. So, that is the case for microwave link to base station. Now, multiple zones and a single base station is there to set up a to make up a call. So, make up a cell. So, that is the concept of construction of microzone cell concept. These are the advantages, and these are the references that you can consider for this particular topic. Thank you.